Although the new James Webb Space Telescope has made headlines with its recent images of deep space, its predecessor, the venerable Hubble Space Telescope, launched in 1990, is still operational and prompting new discoveries, for example, the observation of Earendel, the farthest known star in the universe. The surprising thing about Earendel is its remoteness. The light that the Hubble telescope captured was emitted when the universe was less than 1 billion years old. In other words, the light had been traveling through space for almost 13 billion years before it was picked up by the Hubble. Earendel can only be seen under very specific circumstances, which was why it was one of the main targets of the James Webb, which was launched on December 25, 2021. Fortunately, given the time of year, the telescope can see the southern Cetus constellation which contains Earendel. With its powerful resolution and infrared cameras, James Webb took a new, even more detailed image of the star and the arc of light surrounding it. This arc of light, which makes the star appear brighter, has also been given a name, the sunrise arc. The James Webb will once again point its mirrors at Earendel in order to carry out a spectral analysis to confirm or rule out the presence of heavy elements. So far, based solely on the Hubble and James Webb images, more than 4,700 scientific articles have been published about the star. With stars that are so remote, astronomers don't talk about distance but rather redshift, a measure of how much their light has been dilated as a result of the expansion of the universe. In the case of Earendel, that index is 6.2, meaning it is 28 billion light-years from Earth. It seems like a paradox. How is it possible to see an object at that distance when the universe has only existed for around 13.8 billion years? The star's light should not have had time to reach us yet. The answer to this paradox is that space is not static, but rather expanding at an accelerating rate. When Earendel's light began its journey, the universe was very young and therefore much smaller than it is now. Since then, space has been expanding and the distance between galaxies has become greater and greater. What's also surprising about Earendel is that it is an isolated star, not a galaxy. The oldest galaxies do not appear in the Hubble photos as the pretty spirals we know, but as irregular masses of reddish-hued gas in which no structure can be distinguished. In reality, this color is the result of how the images have been rendered. Earendel is a huge star, or rather, it was, because it has been losing mass for eons. It may be a legendary population 3 star, which were the first to appear after the Big Bang. Between the star and Earth there is a small group of galaxies whose gravity acts like a lens that both concentrates and distorts the light from more distant objects. Earendel is located precisely in a narrow area of that giant magnifying glass where the effect of the gravitational lens is greatest. The star's light can be magnified between 1,000 and 40,000 times, enough for it to be detected by the Hubble. That is, after the telescope has spent 9 hours looking at the same region of the sky. Photon by photon, the telescope has captured the light from Earendel on its long journey across the universe.